Alrighty, welcome back. So now we're actually going to find the inverses of a 2 by 2 matrix. So first off, if you have some matrix with entries A, B, C, and D, right, the inverse of that matrix is going to be 1 divided by the determinant of your matrix multiplied to this thing. Okay, essentially what has happened here is that you switch A and D, right? Because A was in top left, now A is in bottom right. D was in bottom right, it's now in top left. Alright? Likewise, you'll notice B and C, those haven't changed, right? They haven't switched places, but I'm going to do switch places of A and D, and then you switch the signs of B and C. That is essentially all the inverse of a 2 by 2 matrix is. So you multiply by 1 over the determinant, you switch the places of A and D, switch the signs of B and C. That is legitimately inverse in a nutshell. Now keep in mind is that you are dividing by the determinant. Now the determinant can be 0. Question, can we do 1 divided by 0? Is that valid? Answer, no, it is not. You can't have 1 divided by 0. It's breaking the universe, okay? So, essentially, if your determinant is 0, then you essentially don't have an inverse, okay? There is no inverse if your determinant is 0. And if that's the case, we call it a singular matrix, okay? Call it a singular matrix if there is no determinant. So, let's roll with it, shall we? So, example A. Find the inverse of the matrix if it is defined. So first off, we need to find the determinant. That's the first thing we need to do. So let's do the fishy. Okay, so you do first diagonal multiplied together. So -2 times -4, which is 8. Okay, so your determinant of matrix A is 8. Subtract the diagonal of the two numbers, right? So subtract 2 times 3, which is 6. So 8 minus 6, 2. Okay, so the determinant is 2. So then from there, all we say is, okay, so now the inverse is going to be 1 over the determinant being multiplied, and now we change the original matrix A. So we swap these two, so -4, -2, switch places. And then you change the sign of these two. So +2 is negative, +3 is negative. And then you just multiply that scalar, that 1/2 through. So I'd say, alright, so half of -4, -2. Half of -2, -1. Half of -3, there is nothing. So -3 halves, right? Well, not nothing. It doesn't go in evenly, so -3 halves. And then again, half of -2, -1. That is it. That is the inverse of the matrix that you're given. Okay, let's do it again. So example B. So first off, find the determinant. Let's use blue this time. So we do first diagonal multiply, so the determinant of matrix B equals 1/2 times 12. And then you want to minus the other diagonal, so 2 times 3, which is 6. Alright, so half of 12 is literally 6. 6 minus 6, 0. Normally we're happy to get 0, but this is not a happy moment. Because once we get 0, that's essentially saying, hey, you're about to multiply by 1 over 0. That's an issue. No inverse exists. You have a singular matrix. If you can't find the inverse, because there is no inverse, you're done. Alright, example C. First off, we have to find the determinant of matrix C. So we have determinant of matrix C equals, and then we do first diagonal. Let's use, I don't know, maybe it's let's do like a tropical fish. What color would you not normally see for a fish? I feel like purple would be a weird color. But a cool color is like lavender. I like it. Okay, so first, I digress. Right, so you multiply the first two numbers, subtract the next diagonal, so 1 times negative 2, which is negative 2. So we have 24 plus 2, in other words, 26, as your determinant of C. So to find the inverse of C, all we do from there is we do 1 over determinant multiplied. You switch the place of A and D, so 6 and 4 switch places, and switch the sign of B and C. So negative 1, positive 2. Alright, once we do that, then we just multiply the scalar through. So we do 4. So remember, 4 times 1 over 26. 4 is technically 4 over 1. Numerator with numerator, denominator with denominator. So you get 4 over 26. And then we get negative 1 over 26, 2 over 26, and 6 over 26. Now keep in mind, pretty much most of these can be simplified, right? In the first one, you'll notice they're both even. That means 2 goes into it, into 4 twice, into 26 13 times, into itself once, 13, 13, into 6 3 times. Alright, so your final answer would be 2/13, negative 1/26, 1/13, and 3/13. And that would be the inverse of matrix C. That's it. That's finding the inverse of 2 by 2 matrices. Not too crazy. If you do have any questions, let me know. But otherwise, thanks for watching.